Hi everyone. Before I start the lesson, I thought we'd begin with a warm-up question. The question is, a quadratic relation has zeros at -5 and 3. What else can you tell me? So in this case, what the question is really asking are there any other key properties of this quadratic that you can say for certain? And so in this case, you might say, well, you don't know what the y-intercept is, because there's no information about that. You don't know whether the quadratic opens up or down, so you can't say about the concavity. You can't really talk about the a value at all, in fact, so you can't say anything about the shape of the graph. You know the zeros, though. That's good. You don't know anything about the vertex, or, wait a minute, could you know something about the vertex? You know the zeros are -5 and 3, so the vertex has to be somewhere between them. Where would that be? Well, if you think about it, you know that from our formula, the x-coordinate of the vertex has got to be equal to these two, the average of these two x values, just like that. So in this case, I just add them up and divide by 2. So -5 plus 3 divided by 2 comes to -1. So I don't really know where the vertex is, but I know what the x value of the vertex is. And if you remember, that corresponds with the axis of symmetry. So the equation of the axis is x equals -1. And that's really all you can say at this point. Now, I wanted to highlight this question because I want you to remember about how we find points, or how we find values in the middle of two other values. So in this case, we found -1 by taking the average of -5 and 3. That's basically what we do. We add the numbers together and then we divide them. So that's us taking the average. And that's going to show up in this lesson. So this lesson is all about midpoints, and then we're going to get to perpendicular bisectors. So midpoints are basically points that are in the middle of a line segment. So these aren't lines that we might have looked at earlier in the course. These are line segments. So they don't go on, they don't extend forever in each direction. They're only just a piece of a line. And in this case, what we're looking for is we're looking for the point that cuts the line segment into two equal parts. Okay, so we're looking for the middle of the line, or the midpoint of the line segment, as it were. So if we look at the blue line here, this blue line, you can probably look at the graph and carefully decide where the midpoint actually is. It's right there. Right? That wasn't hard. And if we take our x values, you would see that I'll call it M for midpoint. So the x-coordinate is -3 plus 5 divided by 2 equals 1. Okay, so that's why the point that I've drawn here has an x value of 1. The y value is 4, which kind of makes sense because the two ends of the line segment both have a y-coordinate of 4. If you didn't, algebraically, that's, again, my equals 4 plus 4 divided by 2, which is 8 divided by 2, or 4. Okay, so for the blue line, it's not too bad. We can work it out pretty easily, either graphically, if we have a graph, or algebraically, this way. For the red line, it's maybe not quite so simple. Now, maybe if you look carefully, you can realize that the middle of the line segment has to be there. There's our midpoint. Okay? If you didn't see that, let's just watch this here, and we'll work it out algebraically. So in this case, mx is going to equal -3 plus 5 divided by 2, which is 1. We already did that one. And then my is going to equal 4 minus 2 divided by 2. 4 minus 2 is 2. Divide 2 by 2 and you get 1. So the point there that I drew, the midpoint, is 1, 1. Let's write that in. 1, 1. Okay, so that's how you find your midpoints. It's really just like finding the axis of symmetry, but what I've done is I've done it twice. I've done it once for the x, and once again for the y. This slide just basically goes over that again. And again, when we're looking for the midpoint, which I usually use the letter capital M, the midpoint, we get it from the middle of the x's and the middle of the y's. So it's the exact same formula as for the axis of symmetry. We add together the x's, divide by 2. We add together the y's and divide by 2. Okay? So it's pretty straightforward. If I were to do a couple more examples, you can look at this here. So example A, given the endpoints, determine the midpoint of the segment. So the endpoints here are the ends of the line segment. I'm not going to graph it all the time. Sometimes I'm just going to give you the numbers. So it's really not that hard. For A, you're going to go M. If I use the formula as written here, I'm just going to do it all as one. So M equals 3 plus 7 divided by 2, negative 4 plus 2 divided by 2. I'm going to work that out. 3 plus 7 is 10, divided by 2 is 5. Negative 4 plus 2 is negative 2, divided by 2 is negative 1. That's it, so that's my midpoint. Nice and easy. Why don't you pause the video and take a second and work out the midpoint of B. Okay, so for B, for the midpoint of line segment AB rather, you're just going to apply the formula exactly the same way. Now in this case, you're going to get either fractional values or decimal values, whichever one you prefer to use, but that's okay. So for the x values, I have negative 11 minus 2 is negative 13. Divide that by 2 and I get negative 6.5. And for the y's, 3 subtract 6 is negative 3, divided by 2 is negative 1.5. Okay, and that's it. The last thing I'm going to talk about in this lesson is the idea of a perpendicular bisector. Now, this is something slightly different, but it's related to midpoints. So a perpendicular bisector is a line, and it's, as the name implies, it's made up of two parts. First of all, you remember the word perpendicular means that when lines have to intersect at 90 degrees, and their slopes are therefore negative reciprocals. The bisector idea is this new one, and that means that we have to have a line which passes through our midpoint, or passes through the middle. So if you put it all together, this indicates that a perpendicular bisector is a line that passes through the midpoint of a line segment and intersects it at a right angle. So how does this work in principle? Well, whenever you want to write the equation of a line, remember you need to have a slope and a point. Okay? You have to start there. So if we're going to write a perpendicular bisector, you need a slope and a point. The slope is going to come from the slope of your perpendicular bisector is going to be related to the slope of your line segment. It's going to be the reciprocal, negative reciprocal, sorry. And your point is going to be the midpoint. So if I look at this example, example A, I need to work out the slope of this line segment. And I think if I look at it carefully, I see that I'm going down 1 and over 3 each time. So that means that my slope equals negative 1/3. Okay? My perpendicular slope, which I will write as m with an upside down t for perpendicular, is going to be the negative reciprocal of negative 1/3, which is positive 3. So there's my slope. And the point that I need is my midpoint. And my midpoint, again using my formula and using my endpoints, is going to be negative 4 plus 2 divided by 2, and then 2 plus 0 divided by 2. Work that out, and you get negative 1, 1. That's your midpoint. Now, let's be honest. You had a graph here, and you could probably have worked out what the midpoint was just from the graph. But I want to show you where this comes from. So now we have a slope of 3 and a point of negative 1, 1. So what we do in this case is we do what we always do when we want a line, and that is to put it into y equals mx plus b. So in this case, I'll write that y equals mx plus b. Now I know m, that's this value of 3. And I know a point, x and y, that's these guys. What I don't know is b. So what I'm going to do is I'm going to write in everything I know and solve for what's left. So y is 1, m is 3, x is negative 1, so I've got to multiply those together, and then plus b. Okay? If I multiply, 1 equals negative 3 plus b, and if I add 3 to both sides, I have b equals 4, or 4 equals b. Now I can write down the equation. Now I have, so my equation is y equals 3x plus 4. That's my perpendicular bisector. Okay, so that kind of took me a lot of room there, all that. In the second case, I don't have a graph. I have just the endpoints. I'm told the endpoints are negative 6, 1, and 2, negative 3. Okay, so what we normally do when we write these sorts of things is we sometimes label the endpoints with letters, like in this case A and B. So really, though, it's not any different. In this case, though, you're probably going to want to use the formula up here. Okay, so we're going to do that first. And finding out the slope can be a little bit trickier, though, and I'll show you a nice way how to do that. You know what? I'm going to go to another slide. Okay, so here are my endpoints. So in this case, I'm going to first work out my midpoint. M equals, so you know how this is going now, negative 6 plus 2 all over 2, 1 subtract 3 over 2. So my midpoint equals negative 2 when all is said and done. Negative 1. Okay, so there's my midpoint. Now, it's not obvious, I don't think it's obvious necessarily where the slope is of this line segment. So what we do in this case is we write a t-chart. So these are the x, this is the y, and I just write in my points into my table. So I have the point negative 6, 1, and the point 2, negative 3. And so I'm going to work out my change in x. Well, here, this is 8. I'm going over 8, and in this case, I'm going down 4. So my slope equals change in y divided by change in x, or rise over run if you prefer, which in this case is negative 4 divided by 8, which is negative 1/2. So that was the slope of my line segment. The perpendicular slope is, again, the negative reciprocal of that, which would just be positive 2. So again, I have my slope, I have my point, I put them all into y equals mx plus b, and I'm off to the races. So I have y equals mx plus b. Y is -1, m is 2, x is -2, and b I don't know yet. Keep working that out. -1 equals -4 plus b. Add 4 to both sides and get 3 equals b. So now my equation is y equals 2x plus 3. Alright? So that's the deal. We did midpoints and perpendicular bisectors. See you in class.